Hi, my name's Hannah and I'm a sales manager at Izon Science, and today I'll be showing off the features of the Exoid TRPS measurement system. The Exoid has been designed based on feedback from our qNano system to incorporate automated stretching and pressure control systems, removing the tedious manual steps of winding the stretcher and priming the pressure unit. The newly designed voltage clamp amplifier affords the Exoid a significant improvement in the signal-to-noise ratio over the qNano, making measurements even more accurate and repeatable. The Exoid Control Suite software walks users step by step through the entire setup and measurement process. Upon selecting nanopore setup, the software will prompt users with what they need to do to get their system ready for measurements. The user is guided through wetting and coating the nanopore to get a stable baseline. Then the nanopore is characterized by the software to give its detection range. This entire process usually takes about 20 to 30 minutes and gives the user an accurate summary of the nanopore's measurement capabilities at each stretch setting. The Exoid is designed to measure nanoparticle sizes from 1 micrometer down to approximately 40 nanometers. However, particles in the 40 to 100 nanometer size range require an expert user to undertake measurements within this size range, as these measurements often require high levels of user intervention to obtain. Izon sales and support staff provide tailored training to quickly get new users familiar with the tips and tricks of measuring in this size range as part of the Exoid package. Making a measurement on the Exoid is usually simple. Users are prompted to select either a size and concentration measurement or a size and zeta potential measurement for those who are interested in the surface charge of their particles. By following the instructions in the software, step by step, the user will be guided through a calibration process, loading a sample of NIST traceable carboxylated polystyrene particles, or CPCs for short. These particles are then measured by the system 3 times at different pressures to create a calibration curve. Typically these measurements occur autonomously, but sometimes user intervention is required if the nanopore gets blocked by large particles or bubbles. This intervention is usually a sharp tap on the pressure nozzle with the back of your pad, or plunging the system with the plunger. Once calibrated, the user is then guided through washing the system to prevent cross-contamination of samples and calibration particles. This is achieved by washing the fluid cell with fresh measurement electrolyte with a pipette. Once the wash program checks the pore and the fluid cell is clean, the user is prompted to load their sample. The sample is then measured 3 times under the same parameters as the calibration. Each measurement takes approximately 30 minutes, including calibration and cleaning of the nanopore between samples. Measurements below 100 nanometers can take longer if the user is required to intervene, as smaller nanopores are more prone to blockages than larger ones. Once complete, the user can choose to continue on with further measurements or can choose to finish the measurement and clean the system. Data processing is performed on Izon's Data Suite software, which intuitively selects only the calibration files for data that has identical measurement parameters, ensuring users' data is accurately calibrated for precise results. TRPS is an advanced technique providing very high quality single particle data. The Exoid is designed to make these precise measurements in a user-friendly manner. In conjunction with our QEV isolation columns and automatic fraction collector, it provides the user with powerful insights into single particles within the sample. If you're interested in getting high quality single particle data, please get in touch with us by visiting izon.com and letting us know how we can help you.